So in this video, we're going to look at a couple of application problems where we have to use the product rule. So let's read this first one. It says the monthly sales of a new electronic gadget is given by Q of t equals 1500t minus 2t squared units per month, t months after its introduction, and then we have the price that is given by P of t equals 240 minus 3t squared dollars per gadget t months after the introduction. So we have two functions here. We have a Q of t function and we have a P of t function. So what we're supposed to do is find the rate of change of monthly sales. So rate of change, so that you should be thinking derivative when you see that word, and they're asking us to find the rate of change of monthly sales. And if we look at these two functions, the sales is the Q of t function. And they specifically want us to look at 5 months after the gadget's introduction. Okay, so, well, all we need to do is find Q prime of t. So Q prime of t equals, take the derivative of this, we're going to have 1500 minus 4t, and if we are supposed to look specifically at 5, we would have Q prime at 5 is 1500 minus 4 times 5, so that's 1500 minus 20, so that's going to be 1480. So 5 months after the introduction, that's where this 5 is, what that 5 means. The monthly sales are increasing by 1,480 units per month. Okay, so next we're supposed to do the same type of thing, but this time we're supposed to look at the rate of change. Again, we're thinking derivative of price, and again 5 months after the introduction of the gadget. So we need to find P prime of t, and so here's our P of t function. Take its derivative, we get negative 6t. Okay, we're supposed to look specifically at P prime at 5, so we're going to have negative 6 times 5 equals negative 30, and then the units on this, we're looking at dollars per gadget per month. Okay, so this means 5 months after the introduction, the price is dropping by $30 per gadget per month. Okay, now notice that I told you at the start of this video we would be using the product rule, and nowhere in that work did we use the product rule. So let's go to the next page of this one. And here we can see it says find the rate of change of monthly revenue 5 months after the gadget's introduction. So here we're looking at revenue. So hopefully you remember that revenue always equals price times quantity. So in terms of our functions, our price function depends on time, as does our quantity function, our sales function. So this revenue function is also going to depend on time. We're going to have R of t equals P of t times Q of t. Okay, so that's our revenue function. We want to find the rate of change in our revenue function, so we need to take the derivative of this function. So we're going to have R prime of t, and since we have a product here, we've got the P of t function multiplied by the Q of t function. Since we've got a product there, I've got to use that product rule. So the product rule tells us we take the derivative of the P of t first, so we have P prime of t times Q of t, so Q of t stays the same, plus P of t, and now it's Q's turn for the derivative, times Q prime of t. Okay, now we could go through and plug in all of these functions and come up with a function in terms of t, but we've done some of the work already. So if I'm supposed to find this rate of change in revenue at 5, what I'm trying to do is find R prime at 5, which is P prime at 5 times Q at 5 plus P at 5 times Q prime at 5. And in the last part on the previous page, we found that Q prime at 5 was equal to 1480, and we found that P prime at 5 was equal to negative 30. So this here, we know that is negative 30, and this thing, let's see, yeah, this thing right here, we know this is 1480. So we just need these two values, that and that. So I'm going to show you how you can use your calculator to do that. What we're going to do is we are going to go and put our Q of t function in our y1 and our P of t function in to y2. So let's go ahead and do that. So you know, when you turn your calculator on, you're usually in this screen, so we're going to press y equals to get to our y equals screen. And I'm going to put my Q of t function in there, so I'm going to have 1500 x minus 2x squared. And then our P of t function is 240 minus 3x squared. Okay, now I have my function in there, and I'm going to quit out of this screen, so second mode. And if I'm trying to find Q at 5, really what I'm trying to find is y1 at 5. And if I'm trying to find P at 5, I'm trying to find y2 at 5. So I'm going to plug in, so this is y1 at 5 plus, here we have y2 at 5. So this is what I'm going to type into my calculator. So I have negative 30 times y1 at 5, and if you remember from previous times I've showed this to you, to get y1 you press vars, you right arrow to y-vars, you choose function, and we wanted y1, and then we just use function notation, so at 5, plus, now we need y2, so we have vars, right arrow to y-vars, function, and we're choosing y2 at 5, and we're going to multiply this by 1480. We find that R prime at 5 is 20,700. Okay, so let's make sure that we understand the units here. So okay, so the revenue is going to be in dollars and then per month. Okay, so I'm going to write an interpretation sentence here. Okay, so here's our interpretation sentence. 5 months after the introduction of the gadget, the monthly revenue, so we're talking about monthly revenue, is increasing. It's increasing because our slope here is positive by $20,700 per month. Okay, so here we have a second problem, and let's read it together. It says you can sell 40 cars per month at $20,000 per car. Demand for the cars is increasing by 2 cars per month when you drop the price by $500 per month. What is the rate of change in revenue? Okay, so first of all, we're talking about revenue again. And we know our revenue equals our price times our quantity. And I can also tell by this information that's given up here, I can tell a few of the values. So for instance, we can currently sell 40 cars per month. So that's like a quantity. So we have Q equals 40. And we have each car is costing $20,000. So that tells us, whoops, not our Q, our P equals 20,000. Okay, now in this next sentence we have some other information, and let's read this really carefully. So it says demand for the cars is increasing. So demand, we're thinking Q, because that's the variable that goes with the number of cars, is increasing by 2 cars per month. So that's telling us the rate of change in our cars, but it also tells us one other thing. It tells us that it's depending on time. So our Q is really a function of time. We can think of it as Q of t, but for this problem I'm going to just leave it as Q. And when I write the derivative, because this is telling me the derivative, the rate of change in Q, I'm going to use that differential notation. So I have dq dt. So we're told that dq dt is positive 2. Now it's positive because they tell us it's increasing. Okay, and then it says you're dropping, that's a key word there, the price by $500 per month. So that tells us how our price is changing. So that's dp dt. So the price is dropping by $500 per month. So that means our dp dt is negative 500. Okay. So now let's go ahead and take the derivative of our r. So remember, everything in this function depends on time is the independent variable. So we have it depends on t. So we're going to have, when we take the derivative of r, we're going to say dr dt. Okay, and then we have to use the product rule here. So we have two functions that are being multiplied. So take the derivative of the first, we're going to call that dp dt times q plus p times dq dt. Okay, now if we look here, this value here we found right there. This value here, the p, is that value there. The dq dt, that's this value here. And dp dt, that's this value here. Okay, so we're just going to go and plug all those in. So dr dt is going to equal, so we have dp dt, so that's the negative 500, times q, so q is the 40, plus we have our p, that is 20,000, times our dq dt, so that is 2. Okay, so we go and plug this into our calculator if you need to, and we get 20,000. So this tells us, so this equals 20,000. Let's think about our units here. We're talking about revenue, so that's going to be dollars per month because the units of our time are in months. So this tells us that our revenue is increasing by $20,000 per month. So that's it for this video. Come back and watch another one.